Okay, so now I'll invite Professor Hassan to come and lead the panel for the next session.
Okay, so we're going to have a panel, so if the panelists could just please come up, and then we're going to set up the chairs in a few minutes. Okay, so we got the hardest part of the panel is getting everybody to sit at the right spot. Okay, so we're off on the right start. Okay, so first maybe I'll have everybody just briefly introduce themselves, and then after that we'll kind of start for the panel.
Hi, everyone. I am Satish Chandra. I work at Google. I have been working in this area of machine learning applied to software productivity for about 8 years now, and it's been a lot of fun. At Google, we build LLMs and we build tools that are based on LLMs, and these are used by internal Google developers, and we have essentially a lab situation where we can quickly iterate over these tools, deploy to our internal developer community, get feedback, and learn how to do better, meanwhile also improving our LLMs as we go. So let me stop here and pass it on to Ipek.
Ipek Ozkaya, Carnegie Mellon University Software Engineering Institute. My area of work has been focused on software architecture, but mostly for the last decade or so, understanding and managing technical debt. And more recently, the AI tools bring opportunities because using these tools, you can in fact avoid unintentional conformance issues that you might be introducing into your code, but you might also be introducing other ones. So those are some of the areas that we're looking into, as well as applying large language models to higher level complexity tasks like evolving part of a system with subsystem, and when there are multiple dependencies between different areas of the software.
Hey everyone, again, my name is Dayi, and I work at Center for Software Excellence, Huawei Canada, working on the software engineering for AI systems, both in conventional AI and foundational model applications. Thank you.
I'm Dennis Poshavanek. I'm currently at William & Mary. I've been using machine learning for a while now, and I started using neural language code models approximately 10 years ago. And we've done quite a bit of work in terms of applications of neural language models for software engineering tasks. My recent work is actually interpretability. I'll be talking about that later during the day, but we're trying to bring some rigorous methods based on causal inference to actually try to make sense in terms of what these models are generating, in terms of concepts that developers actually can understand. And we're hoping that this work will help to make them a little bit more trustworthy. Thank you.
Alexander Serebrennik. I'm from Eindhoven University of Technology, the Netherlands, and I'm professor of social software engineering. So my goal is to try to help software developers in creating and maintaining software by understanding how they work together, how they communicate, and so on and so forth. And of course, AI is a huge game changer, but we should not forget that software development, at least partially, is still being created by humans with their emotions, with their expectations, and with their frustrations.
Okay, so thank you. So I'm glad my panelists are sharing the mic, but don't share, okay? Everybody has their own mic, almost everybody. Okay, so I guess one of the first things, given it's a panel on developer productivity, maybe we'll start with, in your opinion, what is developer productivity? Okay, so how do you think that should be measured or quantified? We'll do everybody, yeah. Let's do everybody, because that's a key one. I think we need to get the things aligned.
Okay, leave it to Professor Hassan to ask the hardest question first, and I have the situation that line starts here. But so joking aside, I think measuring developer productivity has been a classical challenge for software engineering field for a very long time. So let's try to maybe narrow down the question to what does the use of specific AI tools mean when it comes to developer productivity. So you could imagine many things, such as, the most obvious example is as you are trying to write code, does your tooling save you the effort of going out, searching for information, digesting it, and bringing it back, even if it's copying from Stack Overflow? Okay, can you make that cycle faster? Can the developer expect to have less friction while creating code? And is that happening in a measurable way? So if we can find out units of work that could be completed faster, that is one way of measuring productivity. I also want to refer to not just writing code, but more of end-to-end life cycle in a way, at least from writing to committing code. And there are other places in between, such as code review. So you could also imagine, can AI-based tools impact this process of writing code and submitting to code review and so on, such that the speed at which the developer finishes preparing a diff to be submitted to the time it is actually submitted, can that time lag be shortened, because that can help productivity? So this is more in the sense of a team level productivity rather than an individual level productivity. And we can go on from there. So these are some examples, but I am also curious to hear from my co-panelists.
So I agree, asking the hardest question first. I think of developer productivity as bringing three components together. There is the measurement side of this: better, faster, cheaper, obviously, right? There's, you're able to write code fast, more efficiently, whatever that measurement might play into. However, there's the output quality of it. You're not only writing faster or more efficiently, but are you delivering what you're supposed to deliver? So that's one component. But the third and most important component is developer well-being. Is the developer feeling at ease, supported with that task, and able to complete the task without frustration and cognitive overload, and able to interact with it and be more engaged with some of the tasks? And mundane tasks are less, and more engaging, cognitively challenging tasks are really what they're taking effect. So those are, there's no one-size-fits-all metric for that, but I think that's what really is the optimum developer productivity from my perspective.
Thank you. So I know we're trying to narrow the question a little bit, but I'm actually trying to expand developer productivity, because if we're thinking software, or the outcome of the software is the concept is expanding, then the concept of what is developer is also expanding, right? We're seeing that now even non-traditional coders could be developers for software systems. In this way, I think we know that directly measuring numeric metrics of the outcome sometimes is not the best way to measure productivity. So maybe we could look at it as the ratio of time spent on different tasks, and see that for novice users, or like software makers, and also professional developers, how much time is spent in actually solving the core problem versus how much time is just to figure out the environment, figure out all the other things. And optimizing the time that's spent in the core part for both the makers and professional developers is an indicator of higher productivity in my mind. Thank you.
So I'm not going to try to introduce new metrics which have been already proposed by the panelists, but I just want to bring light to another issue here. And this issue would be that these all proposed metrics that we've talked so far, these are aggregated measurements. And we like aggregated measurements very much in software engineering. You pick any paper and it's pretty much aggregated measurement. So I would actually argue that, especially when it comes to productivity, we need to look into segregated measurements. Or we need to actually get different views into those metrics that we're going to be computing. In particular, just a simple example, you can compute any of those metrics that you proposed, but then if you take different context, whether you're building Android app, web application, et cetera, you can easily find so many different confounding variables that's going to have impact on this measurement. So in addition to whatever metrics we're going to come up with as a community, we also need a rigorous methodology to evaluating the result and interpreting these productivity measurement results, and obviously estimating the impact of so many confounding variables, especially in the light of using all these non-deterministic machines that we're putting to work.
So a lot of actually very valid points have been made. It's, the pleasure of being the last on the panel. So well-being has been mentioned, measuring challenges and essentially dubious notion of measuring at all have been mentioned. I would probably add the notion of teamwork in the same way Satish was referring to productivity at the level of a team, but then mostly with focus on communication and collaboration. Individual members of the team might essentially feel quite well, but if they don't feel the belonging, and if they do not communicate in a professional and at the same time human way, then the entire team will of course be screwed up. So I don't want to say that the productivity value, this will go up or this will go down, but rather that we will observe all kinds of suboptimal communication scenarios which will be affecting the outcome, both in terms of process and in terms of product.
Okay, thank you. So I guess, given there's a lot of industrial folks here in the crowd, and a lot of them are seeing Copilot and the numbers coming from GitHub, now me as an industrial leader trying to adopt this in my own company, what are the questions I need to be asking myself or asking Copilot, whichever coming was a new tool to me? Is the number of accepted, suggestion the right number? Should I really be thinking a bit deeper on that? And what are people's thoughts? And we'll have it open so Satish doesn't have to be freaking out. Okay, he wants to go first. Good.
So if you are running your own company, you should really measure on your own. I think that's the best advice I can give, because as other people hinted at, there are lots of moving parts. Any one metric does not always reflect the full reality, right? So your acceptance rate versus what is the size of output, so to speak, the model produced, versus how many times you may have needed to roll back what the model produced, realizing later what went wrong with that. Factoring in the time it takes you as a human to understand the output of a model and all of these things, right? So there is the end effect on what a software developer feels in terms of whether the model is making them more productive is quite complex. There are many things going on. So I think in the end, it depends upon what works well in your situation. And other factors would include that, do you have such a proprietary code base on which maybe you need to actually do something on your own to make those the models more effective, as opposed to just working off of a completely generic model. So this then depends upon what is your budget situation. Can you afford to customize these things, or you really need to work off of just a stock model and so on. So in terms of decision making, I think there are many factors to be taken into account as to what to consider.
So I'm thinking that accepting a code piece or not is really not a binary situation, but a long-term situation where it could be accepted immediately, but changed after a while, right? So whether it's accepted or not might not be as good an indicator as how long it actually was retained. It could be that, because we know that these kind of Copilot solutions are measuring acceptance or retentions for after 1 minute, 5 minutes, 30 minutes, etc. But even in a longer scale, maybe the generated code has some really hidden issues in performance or vulnerability that, because it was generated, kind of just sneak under people's eyes and stayed in the code, but later causes more issues. So if you're trying to evaluate the productivity boost from this kind of systems or copilots, the immediate acceptance rate, I'm not quite sure if it would be a reliable measure or not.
So I got asked this question last week by a general. And the question was, should I empower my developers to start using it? And there are risks, and how would we do it? And the answer I gave was, pick a low-risk project and start today. Because I think there is a lot of information gathering that we're looking beyond in these tools. And as Dayi and Satish said, there's not going to be one size fits all. So now what is figure out a low-risk area to start today so that you can ask the now what questions effectively. And then for the higher risk ones, maybe these tools are not ready yet. Maybe they will not necessarily reap off the benefits. I don't even know what productivity means in those cases. It might be least number of vulnerabilities as opposed to most number of lines of code. There are different ways of looking at those measures. So there is no one size fits all. You have to really initially silo your organization in terms of what you're trying to accomplish and ask the question based on those silos, I think.
I just want to quickly point out that we're seeing a lot of, obviously, product-related metrics and process-related metrics. That's what we're used to measuring, right? But I think in this context, there is a brand new opportunity, and I see some very interesting work coming out, and I think you pointed out, right, telemetry. So in particular, as we're studying interaction, as we're putting human into the loop here, or LLMs into the loop, I don't know which, we actually can observe a whole slew of other things, like, for example, using eye tracking to study fixations based on what was generated from particular prompt and going back. So there will be a huge opportunity to integrate other types of measurements here to better understand and answer questions.
I would just like to remind that essentially the relation between quality of an answer and ultimate acceptance is strongly mediated by the person who is involved, their confidence, their critical attitude or lack thereof, their experience. It's not only like, takes a low-risk project as Ipek has suggested, but also put people who are sufficiently critical on this project to be sure that even this low-risk project doesn't go south because people simply trust the tool, which they probably should not.
So I guess one of the key things as well is you need to have the platform to get you to good telemetry from your project. So if your software engineering process today does not have good telemetry and tracking in it, you have bigger problems that you need to figure out because it's just garbage in, garbage out at this stage. You can't even measure before and after. And just a basic measure, number of accepts is not giving you the right numbers. So yeah. So I would like as well, instead of only just me asking, I would like to open it as well for the crowd here if there's any questions. Okay. So maybe while people think of questions, I'll continue asking a little bit. Okay. So oh, sorry, there was one there. Hold on, somebody will get you a mic. Well, I can give you the mic. It's coming.
So so thank you very much for everything that's been said. So I guess for me, the question is, do we really think foundational models can improve productivity? I know that's probably like a naive question, but I guess that's the topic here. And in cases where it doesn't, I would love to hear a bit more from the panelists on where do you see some of the pitfalls?
Well, from my perspective, the question is kind of strangely phrased. In a sense, it's not an intervention which can improve productivity. It will redefine the process of software development, and subsequently it will redefine the notion of what does it mean to be productive. So it's not like, it was 17, it's now 42, or other way around. It might have been 42, it might have remained 42. It just means something completely different.
I think one of the questions that we need to be asking, and I don't know whether we're ready to ask, is with foundation models, should we be measuring different things? I think what we're used to is looking into our productivity metrics on software development and all the good old aspects of it, but maybe what we measure will change. There's, I think, that aspect that I don't think we are able to put our hands around yet. And there's definitely areas where they don't improve productivity, because if you're not able to recognize the hallucination aspects and the mistakes, the expertise, I think we're overlooking it, or we haven't come to that using these models does not necessarily always lower the expectation on expertise. It actually increases the expectation on expertise, which might, if you're not an expert, you might be looking for an error that wasn't your error, but it was introduced by the model.
So to try to answer your question, I think the answer is yes. And a couple of things. So you see, if these tools as available to both inside companies and available to public were not suitable for use or not adding value, you won't see the market. So market is a very good corrector of things. Internally in the company, we put out a blog post last year that actually measured a specific metric called edit feedback loop, and we showed at statistically significant level that the time it takes for that loop with and without LLM-based tools actually does reduce with the use of tools. And so that's kind of a fairly objective way of measuring things that they did contribute to productivity. And similarly, when you see adoption of many of these tools that we are still experimenting with and roll out, just the positive enthusiasm that you see, I think is an indicator that they are actually helping people. So I would say measurement can be made rigorous, and we can debate about what to measure and how to measure, but more or less whether these tools are something that seem to be making a positive difference in the practice, I think the answer there is yes.
So I think it's really, I agree with all the panelists' opinion. I just want to add that it might not be a very deterministic answer of whether foundation model can improve productivity, but whether foundation model used by certain type of developers under certain scenarios can improve the productivity or not, because I do think it will be a pretty big factor impacting the effectiveness and actually like which direction the model is impacting productivity in this case.
I just want to quickly say that it's a really, really difficult question that you asked. Why? Because the space, experimentation space, is vast. It's just incredibly vast, right? The number of treatments that you can think of here is just too many to even spot. Like, everybody's talking these days about prompt engineering, right? Prompt engineering is everything that we talk about these days. So the way you do prompt engineering, right? These are all treatments in your experimentation space, right? The way you measure things that we discussed 10 minutes ago, right? That's your outcome that you're trying to measure. We're not even talking about confounders, as you just mentioned, context, task, expertise, and all these things. So vast experimentation space. So as we just start, mapping out, and not to mention that underlying models are changing themselves, right? Which is a huge variable in itself as they're growing. So the answer to your question is, I have no idea. I have no idea. I mean, yeah, it seems like, and that's a quick answer that we like to answer. Yeah, it's making huge improvement, but we have no idea in terms of space where exactly it's happening and why. And of course, there are lots of low-hanging fruits where we like to showcase great results.
I think the only person among us who might have real data is Satish there, so we'll have to probably take it from that perspective. But I think what is really happening with these tools, anecdotal observation, is the excitement of developers is definitely increased. And probably the higher productivity is a little bit related to that. They want to engage with this. They're more excited. They're trying. There's some joy in, like, there is a tool that's going to make my life easier. And I think we cannot overlook that. It has not happened in quite a long time that really focus on developers and how they would be excited. And I think that's a huge opportunity.
So I want to come back to this, the joy and the happiness of becoming a software developer, right? And some of it, what at least we're noticing is happiness, and they're not doing some things that they feel are so redundant and repetitive is, I think, one of the interesting points that people are observing. And as well, the other thing from the GitHub studies too is that it gives you that head start, like that just start. It's like looking at an empty, page, and it gives you that first hit, right? So I think these are some very interesting things which go against the usual definition of what productivity is. So maybe productivity itself is a much more deeper term. It has, Yeah, go ahead.
And I think, I mean, these are very difficult to measure, but one of the things that I'm observing with using these tools within our team is it's providing some of the alternatives that you wouldn't think. Once you're presented the alternative, you're like, you have the aha moment, but you may not be able to think of those alternatives. And that engagement is also providing other productivity boosts that we wouldn't be able to measure. It's like number of alternatives that I've been able to go through in a short amount of time, hence I have better code versus n number of lines of code. I think there are some more difficult benefits as well as risks to measure here as well.
It's like creativity, joy, and actually productivity itself. So May, you had a question, right? May?
Yeah. So thank you so much. Do you think, I mean, if we assume that these are going to make developers more productive, do you think this is going to narrow the gap between the wide distribution of good to bad developers, or do you think this is going to widen the gap between the, like the good developers are going to become great developers, and then is it going to widen the gap? And a follow-up to that is also, how is this going to impact developers around the world? Is this going to make developers in the valley super good and everybody else kind of get left behind a little?
Thank you for the great question. Let me start with the second part. There is a recent work with several people present in the audience, including Masa and Yasu, which has shown that the quality of the answers to programming tasks depends on the language in which those questions have been formulated. And if those questions are formulated in English, then the answers are better than if they are formulated in Chinese. And Japanese is somewhere in the middle. So essentially, the tools which we seem to be having at the moment favorize some developers compared to other developers. If you are thinking about, so the previous study was with Copilot, right? I mean, you are thinking about ChatGPT, it is encouraging tinkering. You are trying to see things, you are getting some results, and if you are not happy, you are repeating this process. Not everybody is a tinkerer. Some people are learning from books or guidelines, and there are gender-related statistical differences. So tinkering is more common among men. Learning from books and guidelines is more common among women. So while each one of us, whatever gender we might be, might use different strategies, those statistically significant differences should not be ignored. So when we are using those tools, we should be thinking about whom we are favorizing and whom we are underprivileging. And of course, language and gender are only two of those dimensions. There is much more.
Just want to add a quick question. So trying to imagine the future, right? Of course, developers will use it. There is no question about it, right? And it's going to be somewhere in the cloud. But let's imagine a day when the service is unavailable. So what happens to that great developer that you mentioned? Or what happens to that average developer that you mentioned? Are they still going to remember how to write getters, setters, event handlers? That's a question that I'm mostly interested in.
Yeah, I definitely agree with the two panelists, and especially as Alexander was mentioning about there are more dimensions than just whether the developer is good or bad. There are language barriers. So I do think it's going to be a multi-dimensional axis where in one way there is the nature or the characteristics of the developers, their skill sets, their background, their knowledge, etc. On the other side is how they use the tool. And the combination of these multiple axes would, in a higher dimensional space, would decide what's the effect. So it would be a little bit hard to just say whether it's going to help the good versus bad developer by some more complicated breakdown.
There are definitely new skills that will be needed with these tools, using these tools. For example, review skills, evaluation skills going to be much more important, which might in fact call the day when the service is not available because I was good at reviewing, I can recall that information. But there's also early studies that are coming out, which is hinting that the diversity gap between different personalities as well as different global regions might open up. Like, for example, who thinks they made the mistake versus the tool made the mistake. Those kinds of things, when we're teaching students, those kinds of tools will become important in terms of, will the gap open or will the gap close? I think there are probably questions that we need to ask to understand how we might actually evaluate those gaps. But it's for sure, if you're an expert, this really, really boosts your ability to do better. If you are not an expert, then you're struggling more initially, even if you might get started quickly, is what is some of the data that is demonstrating so far.
Yeah, I'd like to just add, you probably yourself know high schoolers and maybe middle schoolers who are jumping into very ambitious projects based on using publicly available LLMs. So the barrier to entry and the hitch of, you don't really need to read serious textbooks or instruction manuals or things like that. You could actually get to a reasonable start very, very quickly. And I think analogs of that probably hold even for employees in professional workplaces where these kinds of tools sort of, in a way, ease onboarding into whatever is going on. So I don't know about lowering the gap between experts and non-experts, but certainly it gives a better starting point, and that, I think, is a very helpful contribution.
So I'm going to continue on this, and then I'll let you go. Just give me a minute. So I guess when Google started, well, when Google showed up, or search in general showed up, and even today we know there are some people that are really bad at searching, and some people are really good at searching, right? And at least my feeling is that people are going to be very good at using it. They're really going to fly off. And some people are going to be very bad at it. They're just going to even get worse. Okay, so I feel the gap may actually become much, much worse. So you're going to have, instead of this 10x developer, you're going to have the 1000x developer and the 0.001 developer, really, really bad, right? The question right now is, and a lot of us are agreeing that from the way the market is responding, they're clear there's some value in them. But whether it's to use Google, whether it's to know how to drive a car, we don't just give people that and just tell them go by yourself, right? There needs to be a lot more training, and what really needs to change in how we train developers or how we educate them. Do you think there's something that we really need? First, is it something we need to do? Second, do we even know what we need to teach developers at this stage today? Or is it something we're going to be learning as we go? So I'd like to hear the panel's thoughts on that, or either from your own experiences working in companies or your own actual experience using these tools.
I mean, do we believe there is a standard or a universally good way of using it, or is that a question that depends on the developer themselves and what is the best way for their skill set to use the tool?
Well, so it's the same, like design patterns, architecture styles. These are best practices we know to build software. Is there interaction patterns that we need to be developing, and really, instead of teaching them design patterns, this and this, we say, okay, now there's two classes on interaction pattern with your AI teammates. These are things you need to tell them. Don't tell them, actually one of the classical things is people like to thank them a lot, right? So, and I've seen a study where somebody said, if you bribe ChatGPT, it will actually produce better code. So he said, give me good code, and I've heard there's $1,000 for you in there. So is this something we need to focus more on or not? As educators on that side as well. Yeah, go ahead.
I don't know the answer to your question, but I want to point out something, that you're primarily talking about using this technology to build software 1.0, right? Or writing software 1.0. But let's not forget that we are already train is already leaving the station. We are already writing a lot of software 2.0. So the question is it going to help you with software 2.0? We're integrating that software 2.0 into software 1.0. These are much more interesting questions to me, and I have no idea how to answer those questions.
Well, of course, students already use ChatGPTs and copilots and whatever. The question is, of course, what happens with the commercial side of the things, right? I mean, are we supposed to be training people and gearing them towards using a proprietary technology, essentially, which is not necessarily available for them once they leave the university. Or we should not do it. Because if we don't do it, maybe we are denying them some knowledge or some skill development that might be crucial for their professional careers. I honestly don't know. Many companies that I'm talking to at the moment are very reluctant when it comes to usage of foundation models, mostly because of IP concerns and privacy concerns and so on and so on. So if tomorrow in my class I would expect everybody to use, let's say, ChatGPT, and even if I have a budget for students to play with the more advanced versions, what would it mean for their professional career?
So I think we've seen other technology evolutions in the past that have changed how we think about a particular product or a domain. At this point, maybe it's okay that some developers are 1,000x, and then there are less developers or whatever those roles are. And there are different skills that maybe other developers are good at. I think now these tools are part of our ecosystem, and we cannot undo or unsee them, right? It's here, done. We're really trying to figure out what does that mean in terms of that utilization. I don't think we can ever go back to what it was, I guess, 2 years ago now. So that's important to maybe embrace and engage with it that way. Maybe not every developer has to be really good. Maybe there are new skills and new roles that are going to emerge based on those. And that's maybe a better question to ask rather than trying to create a democratized way of developing this software. Because when a technology comes in, it creates new skills. It makes some skills not relevant anymore. That's maybe a better question, but we will see that. That's how I want to embrace this positively rather than, oh, too bad, we are not going to be able to educate everybody in that.
So I guess one interesting comment from Ipek is that they're here to stay. There's no going back. So maybe really it's not whether they make you more productive or less productive, is how can they, so whether they make us more or less productive is how we can make them, use them the most to be the most productive we can ever be. And I think that's one of the big challenges today, that we don't have a good practices how to do that. And as well, if you don't have the telemetry infrastructure, you're totally in the blind as well. So that would be my other thoughts on that. Yeah, go ahead.
Yeah. Oh, sorry. I think compared to the question of we don't have good practices, I'm more worried about we don't have stable practices, because right now, like the patterns you were mentioning, heavily rely on the current generation of model behavior. And I think we probably need to separate things into things that are dependent on the current techniques behavior versus things are more general, like based on humans' workflow, which scenarios can better be assisted by this solution rather than certain explicit prompting patterns that we write down and make sure everyone memorize, because those things could change in a day.
So, Gustavo, there's a question in the front there. Oh, sorry, go ahead, sorry, I forgot about it, I'm really sorry. Turn on the mic, yeah.
Okay, since we are talking about developer productivity and going to the classics of like no silver bullet for like broke, and like the differentiation between accidental and essential complexities. So for a long time, AI and automation helps in accidental complexities, and this is like contributed to improving the productivity. Now, do you think, like with foundational models and this interactive way of specifying requirements and interacting with the foundational models, we start addressing the essential complexities in different ways, and how this maybe would impact first the way that we educate the students, because like this could be like the focus is maybe like there could be a shift in the way that we, instead of focusing on automation, we could start thinking also of the philosophical part of how to address the essential complexities. So, well, I know, like, but maybe you have some thoughts about that. Yeah.
I think it's a really good question, and I want to get back to this interplay of software 1.0 and 2.0. I think as we are using these foundation models to help us with building software 1.0, they are helping us to deal with a lot of accidental complexity, as you pointed out. And I think that eventually we're going to exhaust that space very quickly. As we start writing more software 2.0, and you can imagine that software 2.0 kind of eats software 1.0. This is Andrei Karpathy's famous illustration, right? We're going to have much more essential complexity, which is not necessary, because essentially you're going to be putting these foundational models as components into your software 1.0 that need to be, created, maintained, tested. So we have new layer of essential complexity, which at this point I have no idea how existing techniques, which are based on foundational models, would help us with that interplay of software 1.0 and foundational models inside software 1.0. So we need more summits, Ahmed, for sure, because.
But I want to come back to this point you raised earlier, right? Which is really maybe the real question is, what is Copilot for prompt programming, right? I think that's what you're trying to get to, right? And we know, in many ways, we're actually relatively good at programming, but we're really crappy at prompt programming. And maybe there's actually more return on investment on trying to figure out how to do Copilot for prompt programming. In particular as well, because A, it's a new area, and second is the type of people that are going to be working in that are much less sophisticated and trained compared to our current developers. So that's, I think, one of the interesting, at least in my opinion, avenue forwards. And I feel, Dennis, you agree, and Dayi, for sure, you agree.
Yeah, for sure. Like as you said, like any new generation software with any new process, new asset definitely could also benefit from any assisted in automation. And we're already seeing a lot of effort. Well, at least partially trying to optimize for certain workflow or certain component, like trying to help the developer optimize how to write prompts and stuff. But there are definitely a lot more research to do here compared to the focus or the resource that has been poured into supporting development of codeware.
I think the prompting and prompt engineering is a huge opportunity for us all to become better thinkers. Because if you think about it, it's really asking better questions. We should all be asking better questions, more specific questions, more concrete questions, so that our interaction mechanisms, that's, I think, going to hopefully teach all of us whatever task it is that we're engaging with in the software development lifecycle. How can I express my intent as specifically, as concretely as possible so that this task becomes easier? I think we take it for granted with the existing tools, and we struggle and we develop all these defect prediction and vulnerability detection and resolution and all those processes. But maybe that's an opportunity rather than a risk from that perspective.
A question to Ipek from the training perspective, from the educational perspective. Should we ask colleagues from social sciences to teach our students? Because, formulating your thoughts, critical thinking, that's what those folks are doing for ages.
Absolutely. And in fact, very good point, Alexander. Thank you. I work with a lot of really hardcore formal methods, like promoting colleagues, and I learn a lot from the way they engage with me, because their minds are trained with that, and it gets overwhelming sometimes when you're not as well trained, but you learn throughout that engagement. And maybe some of those are basic skills that we should be teaching throughout our education system. So it's, again, I think, an opportunity rather than a risk in some cases.
So this idea of critical thinking 101 course being even more important than programming 101 is, I think, a very important point here, at least in my point, because we don't. I think actually one thing I want to highlight too is having worked in different people and different kind of coming from different backgrounds as well. I think North America education has better push to get the students to do that critical thinking, where, for example, in Asia, it's not as strong, right? just because of the education itself, and then that ends up, it's not because the students are not capable, because we know that there's a lot of students that come from Asia that come out the top of the classes, right? And that critical thinking aspect is actually not encouraged. Now, we don't only saying it's important, now we're saying it's actually so essential that even there should be courses on it.
Well, I think one of the problems is that the current tools are doing a very, very good job for very, very simple tasks that students are encountering in Programming 101. And essentially, there is no need for them to be critical because the tools are so good. But by the time they actually need to become critical, it might be too late. So we actually need to rethink not only are we teaching them critical thinking or not, but also like if we are teaching them any form of programming, how are we doing it?
So maybe I have a slightly contrarian view on that. I think actually these tools are helping critical thinking. So I take the example of my daughter who is in middle school, and her assignments are that here is a topic. Do not write an essay on the topic yourself. Go for ChatGPT. Let ChatGPT create the essay, then critique it. I think that takes even more effort than just writing a mediocre essay on your own. So this is obviously a personal example that I pulled out from middle school kind of thing. But I think this sort of ability to critique what a automaton is doing is going to kick in automatically, and in fact, it is going to challenge us more, and people will just become good critiques of LLM work. So I don't know if you agree with me or not, but I wanted to offer
I
that.
fully agree.
Yeah.
I fully agree, and colleagues from mathematics actually doing something similar for probability, classical probability problems, earns 5 balls, 2 red, 2 green, right? So they're asking ChatGPT to generate several solutions and ask students to choose one of them.
Related to that, your comment made me recall a debate that we were having with our data scientist colleagues is that they're reflecting that people are not comfortable with a probabilistic answer. Like this answer could be like 70% correct. And it's probably going to teach us to be comfortable with what that means and what to do with that decision space as opposed to black and white kind of decisions. I think there's a little bit of that skill that we'll need to develop throughout interacting with these tools as well.
Okay, so Gustavo, there was a question in the audience. If there's any questions, please. Yeah, Gustavo, go ahead.
Hello. Hi, hello everybody. So I would like to ask you, what are the dangers or maybe the pitfalls of using foundation models to try to increase developer productivity? So I have a few thoughts of my own, right? So being very concrete, right? So GitHub Copilot is out there, like millions of people are using it today, right? But it's essentially, GitHub Copilot is additive in nature, right? It only helps you to add more and more code. And as a software developer, this is kind of intriguing because a lot of time, I would argue that we're trying to actually shorten code. We're trying to create abstractions to promote encapsulation and reuse, refactoring, right? We're always trying to move stuff around. And then when I see GitHub recent papers saying that even that junior developers are more likely to accept the suggestions. So that can be tricky, right? In the long term, we were talking about end-to-end effects of in productivity or whatever. So anyways, yeah, I would like to ask you, again, what are your thoughts on the pitfalls and dangers? Thank you.
So I think you already touched on some pitfalls and dangers here. Whether humans, code writers or code reviewers are equipped to deal with, to not be lax in their due diligence is important, because ultimately we do not want to create a software production chain where code gets completely, generated and committed without there being enough checks and balances for us to be able to trust that the right thing is happening. In addition to these more of safety concerns, there are also other kinds of pitfalls. So for example, there are intellectual property related pitfalls also that one needs to be aware of, and these are not always very clear about whether you are even allowed to use some code or some other media generated by an LLM and things like that. So I think some of this will probably be worked through governments and society to figure out what is a safe and acceptable use of LLMs in software production and in the world. But I think there is a whole list of these questions that need to be settled down. And correctness, I think, is just one of them. There are all these other things.
Again, I would like to get back to the point that even in the context of our discussion, we're sort of in this two-dimensional space where we're discussing how to use these foundational models to help us generate more software 1.0 code. And this is what we're doing right now, but we also see that a lot of systems in industry, they already have 2.0 components. These are foundation models residing inside software 1.0, like Tesla, for example. So there are certain problems, very challenging problems, that you cannot write software 1.0 code for. I mean, no foundational model can give you the code for, for driving a car or produce code, right? And for that, as we know, we actually need to train that model and put it inside the system, right? So I guess the challenge here is that once we start moving from this paradigm of using foundational models to produce software 1.0 to actually start building software 1.0 plus software 1.0, that's a whole new slew of accidental complexity or essential complexity, right? That we have no idea at this point, at least from our point of view, how to deal with. And this is a whole new slew of pitfalls, right? So eventually, we're going to very quickly saturate in terms of using these foundational models for helping us produce software 1.0. We're going to get there very quickly, right? But then what's next? And next is how that development process is going to look like. Is it going to be code-centric, or it's going to be, software 1 plus 2.0 centric somehow? I have no idea.
One of the important aspects that we're overlooking or have not touched upon is the data. Like when the risks, of course, the privacy and all of those are going to be definitely important. And then if we're generating code using these tools, there's that circular aspects of the data that is being generated and the variety in the data. There's one aspect. There's like the huge amount of data that is generated. That is another aspect. There are tasks that we don't have the data yet and how we generate that data. So there are all kinds of pitfalls around the centrality of the data. There are not as well represented languages, although some of these models demonstrate even with small examples you can fine tune them, but there are not always generalizable from different ones. And again, these scenarios maybe could be considered edge scenarios, but I think we should not underestimate the importance of the data, whatever task we're talking about, that goes into the success or potential risks as the outcome.
Thank you. So I believe there are a few aspects about this problem. Firstly is that if we think about the traceability, because we are producing a lot of, well, in a way, it's also related to data where we were producing the data that was trained on back to the cycle again, right? So I think we have as much a challenge as an opportunity here, where if the Copilot was designed poorly, then we're actually polluting the data with a lot of bad code, but we could also, it also means we also have an opportunity where if it has built-in good practices, we could be producing a lot of good quality code as well. But the most important thing is that the telemetry or any kind of system needs to be able to separate which code are generated by foundation models or copilots and which ones are written by humans, so that at the end, regardless of whether they are better or worse, we have certain level of controllability over how that data is going to impact our system's evolution.
Okay, there's a question in the front here. Yeah, Pick.
Hello, I'm Big from the University of Melbourne. So thank you for all the comments and discussions. So based on the discussion, I can see that we have to do the code review on the code and everything. But then there's a lot of research on automated code reviews, and we more like become moving on the agentware, where like generated code and then code review, and then it could be automate repair and everything. So how do you see software engineer or human be the part of that loop of the process when we become to the agentware? Thank you.
Take a crack by rephrasing your question to make sure that I'm understanding correctly. So your question is, okay, we can talk about code review processes, improving those when we're talking about code as the unit of construction, but what are the skills of the humans when we're talking about AIware? Is that correct? So I think the review skill does not necessarily go away, right? You have a requirement, you have a specification, you have a goal, and you need to accomplish that goal. Whether you're implementing it using code, or you are interacting with the foundation model and it's data that is giving you the answer, does not necessarily matter in that case. You're still evaluating the outcome, or you're evaluating whether the data is fit for that. So the evaluation skill, I think, is definitely going to be important. It's just what you're evaluating and what kind of formalisms you need to know in terms of what you're evaluating probably changes with that.
I think that the boundaries of automation are essentially legal. We can think about automated code review, but as long as there is some form of legal requirement that a human being signs off any change, there should be some kind of human involvement. If this legal requirement is not there, that will be a very different world, with maybe very different interactions, like maybe foundation models can produce software, and this produced software can actually go to the outside world, but everybody who is interacting with the software is allowed to press a big red button and interrupt it. That would be a very different story, because at the moment we have the guard before software goes outside.
Let me tell you my thoughts, I guess, is, I guess I'm the head panelist, but I'll just comment anyway. The reality is you will never get it human, because we always need humans to know what needs to be done, okay? So even if we get rid totally of code, unfortunately we're limited by the intelligence of human to tell us what they want. Which brings us back to something that we have been ignoring for many years, which is requirement engineering. Requirement engineering today is one of the least efficient processes today, right? And a lot of times, the definition of requirement engineering for some of the professors is like getting what the users want out of their brain without actually killing them, right? Because it's a very extensive process. There's a lot of going back and forth in it. And I think moving forward, improving the efficiency and the productivity of a requirement engineer, and maybe in this case, it's not a real requirement engineer, it's actually a requirement engineering bot that can figure out how to talk with a human and walk through them the process, is something, I think, a very big challenge moving forward in this agentware and mindware world. So one of the things I want to kind of end with, at least, so, somebody gave me a bag with $10 million, actually. Okay, so I have $2 million for each of you. Okay, and there's enough smart people here from different companies, so they will jump and help you. So if you have $2 million, 10 people, what would be a project you think that's most important you would like to work on around productivity, in software engineering today? And give you a few seconds to think. Okay, maybe we'll take that one question in the back. Yeah. Oh, there's multiple in the back. Okay, good. So people are trying to buy you time, but you're gonna have to answer that question because I need to get rid of the money.
So, hello everyone, I'm Profir from NII. Thank you very much for the very interesting discussion so far. I actually want to jump back a bit to some of the points that were made scattered about. And precisely, I mean the point about how to formulate the prompts, how important the prompt becomes in software 2.0, especially in terms of the new interactions, the new modalities that can appear when we're stacking multiple foundation models. And I guess this is a lovely touching point for just before the question point about requirements engineering. Do you think that the job of a software developer in the future, especially with the point about formulating precise prompts, becomes more requirements engineering than current day software development?
I think that task is already in our job charts. We just don't take it seriously. Like, I've been dying to say this since the Shona meeting, so you may or may not be familiar. There's a series of books, children's series in the United States, maybe it's all Amelia Bedelia. And in one of the books, Amelia Bedelia is a housekeeper, and she's giving requirements, and the requirements, one of the requirements is dust the curtains and the furniture. So she puts powder all around the furniture and the curtains. So there are all sets of these kinds of like anecdotes with the requirements. So these are already part of our day-to-day jobs. It doesn't matter. The tester has the requirements, and the requirements engineer and the developer. It's just, I think we'll need to take it more seriously.
Sorry. I think in a way, prompt is also beyond just one-way communication of specifying the requirement, but more of mechanism for communication. Because if we're thinking of it just giving instruction to the model, it's a single-way situation. Of course, it's very important, but a lot of times, how do we do prompt is that we also need to know how model sees the prompt, or how foundation model perceives things, or acting, or behaving. So this kind of very similar to the traditional communication, where you need to know the people you're talking to and communicating to, how they perceive knowledge or how they perceive information to decide how you actually talk to them. So I think that's another way of looking at what software engineers are doing when they are prompting. They are actually communicating with the model.
Well, yes, I just want to comment that it's essentially sense-making, right? Different people have different interpretations of the same situation, different expectations, and so on. So in this sense, I don't think that one can ever get to some kind of crystallized list of requirements. But of course, those foundation models can help us with interpreting those problems.
Was there another question in the back there? Okay, yeah. Okay, last question, and then you guys are gonna get me rich. I need to get rich. Okay, last question, please, go ahead.
Sure, hello. I am Babar from Huawei. So we are discussing abstractions. We have abstractions at various levels, from machine language to assembly language, then to high-level languages, then to LLMs now. So do you think there would be more such abstractions? So I think LLM is something that's closest to the natural languages. At the highest level, we write code in natural languages, then LLMs help us to write the code in programming languages. So do you think there would be more such abstractions, like perhaps there is this speech recognition, we can use that will help us to write the code, and we can just think of using the neurosciences, and there will be some machine helping us writing the code? Thank you.
So I think, human language has been sort of a very long, process of evolution of humanity itself. And if you communicate in human language to a computer, then, that is, in a way, it's an ultimate form of communication already. But I think maybe the intent of your question is that language itself can be used at many levels. So you could give a very detailed instruction of what needs to be done, and the computer, in this case an LLM augmented computer, is essentially formalizing and transcribing what you said. But you could have given the instruction in perhaps a higher level way or maybe a more ambiguous way, and then as LLM technology matures, it may be able to create a plan for what needs to be done. If there are ambiguities, come back to you, and so forth. So you could become more goal-oriented over time, where you tell the LLM what needs to be done, and it figures out more and more details. So I think this transition I see is already happening. So even if, because in both cases you are using natural language, but the level at which you are using the natural language can be raised, and the computer does a lot of thinking, so to speak, on your behalf. Another thing, I think you referred to speech, but there is also visual aids. So as you know, vision transformers have taken off, and their capabilities are amazing as well. And so it's possible that you may be able to convey your intent a lot more using a combination of human spoken language or written language and sound and images, or maybe even videos. And the computer can digest all of that and help you get your job done. So in those ways, I feel like, yes, you know, natural human senses involve vision. Smell, I don't know if anyone is working on smell. That's, you know, that we'll table. But, you know, speech, vision, and language, these are the three natural forms in which humans sense. And I think computers are getting close to dealing with these forms of communication.
You gonna answer that one, or are you gonna make me rich?
I'm not sure.
So maybe you want to answer quickly on that one, or
no? Just very quick comment. I'm not sure that we're going to be keep raising abstraction level, right? Because for certain types of systems, you need math, right? I mean, for mission-critical systems, you need formal specifications. You're not just going to be throwing things at LLM to generate code. So I think an opportunity that we may see here down the road is actually making natural language more interpretable. So you could think about potentially some domain-specific natural language for helping you to produce code in certain domains so that it encodes or helps you capture certain constraints. And things like that. So it's more like refinement of natural language, but I seriously doubt we're going to go up in some sort of abstraction level here.
I mean, I don't know if you know, but like China has a big push to teach AI all the way even at kindergarten, right? So the question is basically, if I understand you correct, so you're going to have like an English class and a agent talking class, you know, talking to agents, right?
If we figure out how to do it correctly, then yes.
Yes, yeah. So very interesting. So, okay, we're back to the real question here. I'm here to make money.
Well, let me just comment before we are there, right? Continuing on Satish's idea, right? I mean, natural languages obviously include non-written languages and, for example, sign languages. So it's not so much about level of abstraction, but about diversifying the input channel. It's not only typing, and it's not only typing in English.
Yeah, makes sense. Okay, so let's go quick. That's the final thing. So what would you think would be the most important thing? It could be the most important, you think, with the most doable, the lowest hanging fruit maybe, right, at this stage?
Well, if I would have had a lot of money, then I would definitely try to really implement this slogan that foundation models make everybody to a programmer. So I would really invest in diversifying, like in looking at how this kind of solutions can make a more inclusive world.
I guess I'm not going to go too far from my research, and I'm just going to say that in order to implement all that vision that you mentioned in your introduction, we need a lot of plumbing. A lot of plumbing needs to be built to enable that infrastructure that you're envisioning. And what I mean by that is that, yes, we're interacting with foundational models a lot to produce code, so forth and so on, but I think the next step would be to enable much more actionable interpretability, so that we can actually get much better insight in understanding what models are generating and whether they really capture the concepts that we're expressing in prompts, and providing us with really good assurance mechanisms in terms of if this generated code for this particular prompt, does it really take into account the concepts that you intended to express in that prompt, so forth and so on. So just building the plumbing to enable that, to enable the rest of the things that you have in the slides, we need really good infrastructure. So this is where I would bet $2 million.
Thanks.
So I think from my observation, the most expensive parts in building these kind of systems are in the data part, right? And assuming we do have the money and resources, I think to build the whole infrastructure that can crowdsource all the knowledge from across different demographic population to curate the highest quality data set to power various different languages of programming languages, usage scenarios would be something that you cannot achieve without that kind of investment. So it would definitely also help with the diversity of the application, not just focusing on mainstream languages as well.
So I think I would focus on simplifying some of the way we're expressing these programs. I think there's a lot of unneeded, unintentional complexity that these models are learning from, which will probably result in us creating a lot of complexity that we don't need, and like maybe revisit that. How do we really simplify, and would these models help in terms of us writing? Somebody said, I think, more code is not the goal. Can I accomplish things with less code, less data, so that I have more manageable corpuses rather than being overwhelmed with everything, which will stress the infrastructure, has sustainability problems, and so on and so forth. So, and 2 million would not be enough.
So $2 million is actually not a lot of money, to be honest.
The two people in industry
no,
want more.
If you have $2 million too many, can you please send them my way?
How large of an LLM do you think you can train with $2 million if you rent GPU on the cloud? So yeah, right. So it's not.
Well, I'm hoping Google's going to give me some discounts. Okay.
Okay, but so in terms of like maybe we talk about like what are the new interesting use cases that need to be looked at from even existing LLMs. And we talked a lot about writing code, right? But there is also a huge amount of work that we do in the so-called outer loop, right? Like, bugs appear in production, and there are release management things, and logs get, gathered, and they need to be examined, and someone needs to do lots of maintenance activity. And that is actually quite a bit of work. I would say a significant number of employees in any large software company are involved in doing that kind of work. And I think our community sort of has overly indexed on perhaps producing code as opposed to also looking at all these outer loop processes. So if I had to, pick out a new research topic to fund or to start, I would look at some of those and see where we could add real economic value by bringing LLMs into the story.
So thank you for the panelists. I just have a very quick summary. So there was a lot of very interesting ideas today. I think the couple of key things, at least to me, is these tools are here to stay. The marketers already voted, the developers have already voted that they actually see value in them. Okay? The question is not whether they're productive or not, is how we can make ourselves more productive with them. So that's be one thing for me that comes out. Second, I guess Satish's point is there's much more to software engineering than coding. The whole outer loop needs to be explored. There's a lot more potential here. This is much more lower hanging fruits happening in there, right? And even going back to some of Dennis's comments about, we're not going to be doing code anymore, right? Can we even have Copilot for prompting it, right? So there was a lot of interesting idea today, and I hope throughout the day, you reach out to these folks. They're all looking. I promised them $2 million. I only have is $20, okay? So please, throw them a couple of money, and they're going around. So I will thank the panelists one more time. Okay, thank you. We're going to be passing this around for money, okay? So we're gonna break now, but first we're gonna all come to the front to take a group picture for the memory. And then after that, we're gonna go for lunch, and we're gonna be coming back at, what time we come back? Is it 2? 2:30. Okay. Okay, so thank you. So please come, we'll have a picture as a group, please, yeah.